Hi guys, this is Mark. In the previous video, we talked about the where clause structure. And in there, I mentioned that the values that you use in the where clause, they must match the data type for the column that is being referenced in the where clause. And the same is true for the operators. So operators will vary depending on the data type that you use when you reference one column or the other. And in this video, we'll be talking about available operators and see how they relate to the data types of the columns that are being referenced. So let's just go over all the available data types and see what kind of operators you could use in the where clause when you define those conditions for the queries. Starting with numeric data types, they are integers, decimals, doubles, and auto number data type. The operator that you can use whenever you create that condition can be any of these 6 operators that are listed here, specifically equals, which is pretty straightforward. When you reference a column and you specify a numeric value with the equal character, it means that all the records will be retrieved where the value in the referenced column equals the value that you specify in the where clause. The exclamation point equal stands for not equal, which is the opposite of the equal operator. And all the other ones are self-explanatory. Greater than equals, greater than, less than equals, and less than. So here you can just derive different types of conditions that you can build using all of these operators as they relate to the numeric data types. In the previous video, we were playing with a rating greater than 4, I think, and you saw how that works. So with these, it's pretty clear. Let's move on to the next one. So text data types, and these are columns declared with a string, text, multiple choice, or color. All of these internally, well, string and text, it is pretty clear. It is string, multiple choice, and color. Those are going to be stored as text as well. So for these, whenever you reference columns of these types, the operators that you can use are equal, and in this case, you specify that the value in a certain column must be specific value that you identify. Exclamation point equal, or not equal, is going to be the opposite of the equal. Is null and is not null will give you an ability to retrieve records where a specific column contains either null value or a not null value. And like and in are a little more advanced. I will specify, I will actually show you specific examples once we go through these slides so you can see how they work. But briefly, I will describe that like gives you an ability to do retrieval of the values where the value in the specific column matches a certain pattern. And like, the like operator is the one that gives you an ability to retrieve records where a text value starts with a certain character or substring, ends with a certain substring, or contains a substring in its value. And the in operator gives you an ability to retrieve records where the value is one of the specified options. And you can have multiple options for the in operator. Again, there will be an example where I will demonstrate how it works. Moving on, datetime. So datetime columns, they contain a point of time represented as a timestamp. And the operators that apply to the datetime columns are greater than, and the synonym for that would be after. So you could either use the greater than character or the word after, and it's going to be exactly the same. So you can say, let's say date of birth column after, and you specify date, or timestamp as the numeric value. Less than is going to be the same thing as before, and in this case you can get all the records where the specific datetime column value is before a specific value that you identify. Greater than equals, less than equals, self-explanatory. This way you can get the records that contain the value that contains either specific timestamp or anything that happened before in the timeline, because datetime values, they land rather nicely on the timeline because they identify a point of time. You can combine multiple conditions in the same query if you want to identify a range of dates. So you can say column name and specify the name of the column for the date, time, and after certain timestamp or date, and then you can say and column name less than. So this way you identify a range, and then the database will return all the records where the values of the identified column fall within the specific range that you have identified. And finally, we have Boolean data type, and Boolean data type contains true, false, but you can reference values as zeros and ones. So you can say column name, specify the name of the Boolean column, and say equals 1, and it's going to be the same thing as true. Or you can say equals true, or not equals true, or greater than 0, and it's going to be the same thing as 1. So you get an idea. It's very similar as with the numeric data type. However, the actual values are going to be true, false, or 0 and 1. So these are the operators that are available for various data types, and let's take a look at how this would work with specific examples. For this, I will switch back to Backendless Console, and let's start playing with various operators. So here we have, let's say, the product table, and with numeric data types, for instance, price, it is money, and money it is a numeric data type. We can say price greater than 20. Click go, and then in this case, we're going to get all the records where the price is greater than 20. If you want to do a range, you can say price greater than 20 and price less than 50, or let's say 30, just to make it a narrower range. Click go, and then these are all the records where the price falls within that range. Let's with strings. So I wanted to demonstrate with strings. So here we have, for instance, a category. It is a string type, and then category equals gadget. Click go, and then we're going to get all the records where the category is gadget. In the where clause, whenever you reference a string, it needs to be in single quotes. And I think in the previous video when I was presenting slides, it was in double quotes, and I hope this will not cause a confusion. It was really just for the presentation in the slides. In the application, whenever you are composing a where clause, any values that are strings, they need to be in single quotes. So, let's say if we do not equals, which means that get all the records where the category is not gadget, click go. And then these are all the categories where that is not gadget. Let's introduce one product where the category is going to be null. So click new to create this record, and test title. And let's say that's all it has. So now we did not provide it a value for the category, so we can say category is null. Click go. And now we got this record where the category does not have value. And if we say is not null, we're going to get all other records that we already had in the database. So that's how is null works. Like, let's talk about like. Like is a powerful one. So like gives you an ability to run searches based on some kind of pattern. So the way it works is you say like, and then you need to specify a value that can use special characters. So those special characters are, it's actually a %. So let's say if you want to find all the records, all the products that start with W. In this case, we know it's going to be widget. So for this, you put W, and then you put the % character. And the % character substitutes everything that could follow W. In this case, click go. And as you can see, we got all the ones that have that start with W. I'm not sure if we have any if there will be more than one different type, but let's say we can use % both to start and to end, and inside if we put, let's say, character I, which means that find any record or all records that where the category contains letter I. Click go. And see, this is Gizmo, widget, and so on, simply because all of them contain letter I. And the way this should be interpreted is that it can start with anything, it includes I, and it can end with anything. And as a result, you can actually see that it does this pattern matching. So if we do IZ, which will definitely catch Gizmo, click go, and it found all those records. So like is quite powerful because you can pretty much find anything that starts with a certain character or substring, ends or contains that substring. Finally, in was another parameter, was another operator that we looked into, and in works like this. So you put in, and then in parentheses, you can identify all the values that record may contain in that column. So for instance, if the category in, and we put gizmo and widget, click go. In this case, we got all the records where the category is either gizmo or widget. In is more of a compact version of doing the following. So you can say category equals gizmo, or category equals widget. And the result is going to be exactly the same. So using in and then specifying all the values in parentheses separated by comma is going to be exactly the same as using this or operator and referencing the same column multiple times. So that's how the in operator works. Basically a shortcut for doing this or type of query. Let's take a look at booleans. So for booleans, what I will do, I don't really have any boolean columns in the schema that we have imported, but what we will do is we'll go to the review table, and in the schema, we'll create a new column called is approved. In here, let's select boolean, and let's say that the default value is going to be true. Select this for the visualization purposes, click create. Go back to data browser and let's just select a couple that are, let's say, not approved, just for the testing purposes. So to work with the Boolean columns, you can say is approved equals true. Click go. And in this case, we get all the records where is approved is true. You can say not equals true, which is going to be the same thing as false. And now we get the ones where it is false. You can say greater than 0, which will be the same thing as equals 1 or equals true, because Boolean contains only 2 values. So that's working with Booleans. Finally, let me demonstrate how you can structure queries with dates. And for this, if we go to customer, there is a column called birth date, which is of the date time type. So in here, if we say birth date equals let's say 03, let's pick this one, 03/13/1997. Click go, and actually found it. The reason it found it is because notice that the time here is all zeros, and then I did not specify the time. So if you don't specify the time, it will assume that the time is all zeros. However, if the birth date here had different timestamp, then in a specified birth date, just month, day, date, and year, it would not be able to find it. So it really needs to be exact match for the value that is in the database. As far as after, if you click go, so it's going to find all the records that where the value of this column are after the specific date. Okay, or if you do before, then it's going to be anything that is before. To specify a range, you can say after this and birth date before, let's say 01/01/2000. Notice that the actual values for the date I'm putting into single quotes, so that because that's the format that is expected. So click go, and then it found all the records where the birth date is within this range. Very, very straightforward. And what I like about where clause is that it reads really well. When you look at the where clause, it actually makes sense just when you start reading it. You can understand from the perspective of what it's supposed to do without going into some cryptic formats. This is it. So this is a fairly foundational knowledge that you should have when you structure a where clause. It will get more complicated because there is a lot more that can happen, and you'll be learning about it in the videos that are coming up. I hope it makes sense. If you have any questions, please leave a comment. It is very important we hear back. but I hope this was useful. Thank you for watching, and as always, happy coding.